The next frontier of engineered systems is really going to be human-machine systems, this interaction of humans and all the things that we're creating. And a prime example of this are autonomous vehicles. And fundamental to that is you trusting that your car is actually going to do the right thing. It's kind of scary, right? To be driving and let go of that wheel and trust that it's going to stop when you get to a red light. And so if we want to integrate, in some sense, these machines and robots into our society and have them help and collaborate with us in the way that we want, we really need to design them to interact with humans in a way that will make humans feel comfortable, that will make humans trust them and want to work with them and rely on them. At its core, trust is what drives collaboration. That's true of human-human teams, and it's no different in human and machine teams. And there's been research actually for decades trying to understand how humans trust machines. What we do not fully understand, and what I'm so excited to be tackling with my research group, is giving machines a way to sense or estimate how much the human trusts them. And the way that we're approaching this problem is through a combination of machine learning algorithms and psychophysiological sensing. Some of these are built into things like Fitbits and smartwatches today. One that we use is called EEG, or electroencephalography. And so through designing experimental studies and collecting lots of data and then applying classification algorithms, which are a type of machine learning algorithm, to that data, we can actually classify whether a person is likely in a trust state or more likely in a distrust state. A first step towards coming up with a way in real time to help a machine understand, okay, I think this human is trusting me. I think I can interact with them in this way. Or maybe, I'm sensing that they're distrusting. How might I change the way that I'm approaching them? And you can imagine something like this being really important in the case of assistive robots in a nursing home, for example, interacting with someone elderly who may be uncomfortable with the fact that their in-home helper is actually not a real human, but some type of robot. As a mechanical engineer, I never anticipated that I was going to be working on a project that involves psychophysiological sensing. The field of human-machine research is a growing one, and we really need a new, sort of a next generation of engineers and scientists who understand how to do that.